So because of the fact that we have this polarity and the ability to form hydrogen bonds, we get these beautiful properties of water which make all of life on Earth possible. Property number one, water can be sticky, okay? And when you think of sticky, you think of like tape, right? So water has the ability to be cohesive, and cohesion means that a water molecule sticks to another water molecule. So when we look at this drawing, again, you see those hydrogen bonds holding this molecule to this molecule. Well, we can create a whole network of these, and that produces some very interesting effects. For example, have you ever tried to pour a glass that was just too full and you poured it too slowly? Okay, water molecules are going to stick together to keep that stream of water all together. Another property that makes water sticky is adhesion. Water is able to stick to the surface. So when you're pouring that water out, it's trying to leave the surface of the glass, but it's attracted to the surface of the glass, and so it stays stuck to it. And that's usually when you're trying to pour into something that's over here, but instead the water dribbles down the edge of the glass, and usually like on your pants or something. So water is sticky. It could stick to itself, cohesion, together to each other, or adhesion, it can stick to something else. All right. Why is this important? Well, because water can stick to itself, it can form long chains of water molecules, and that's going to be important in how plants are able to move water from where they absorb it in their roots all the way up against gravity to, the leaves and out to the shoots. In addition to that, because water is sticky, okay, cohesion and adhesion, it almost turns it from being a fluid into a solid. And so we get this unique property called surface tension, and that allows water to have some tension. In other words, it acts sort of like a solid in a way. And we can see that demonstrated here with this water strider bug. Here, this insect is able to walk across the top of the water because those water molecules are sticking so strongly to one another that they're resisting being broken through by the body of the water strider insect. Okay, property number two, water is a versatile solvent. Okay, so introduce some terminology here. When you have a solution, let's say you pour some salt into water, the solute is the substance that is dissolved, and so in this case that would be the salt, whereas the solvent is going to be the substance which is doing the dissolving, and that is going to be the water. And what do we mean by dissolve? So when something dissolves in water, that means that it is going to break apart, is going to dissociate or come apart into pieces because it gets along well with water. And that's why we use the phrase like dissolves like. So a polar molecule like water gets along well with other polar molecules, whereas a nonpolar molecule gets along well with other nonpolar molecules. So what happens when you mix a polar and a nonpolar molecule? Well, if you try and do that, you're going to get a resistance. And I'm sure you've seen this if you have taken water, a very polar molecule, and you add oil to it, which is nonpolar. Do the two mix very well? No, not at all. The oil sort of globs together and stays as separate as it can from the water. It's very water-fearing, or what we say, hydrophobic. Okay, here's a term that you might want to know, hydrophobic. And what that means, let me just, right here. That means water, I gotta work on my handwriting, right? Water fearing. There you go. Okay. So in plants, for example, you feel that waxy surface, they're going to repel water, and it's going to sort of bead up because the water molecules will be attracted to each other and they will repel the waxy surface. So they're going to separate. As you can see here, all the water molecules are sort of on their own, and then in the center you have all of the hydrophobic molecules. They're trying to stay very close to one another because they don't like the water. They're like, ew, get away from me. Salt, on the other hand, is hydrophilic. Okay, so if hydrophobic means water-fearing, hydrophilic means loving, water-loving. Okay, so because of that, salt is a polar molecule, water is a polar molecule, so salt will dissolve in water. And what that means is we can break salt down into its pieces. So here you see we broke salt into a sodium ion and a chlorine ion, because that's how salt can separate. And that's what allows it to dissolve into a solution. Another property, water has a very high specific heat. And what that means is the specific heat of a substance is how much heat is gained or lost when temperature is changed around it. And lucky for us, water responds relatively stable to changes in temperature. And here's what that means. Okay, I have an amount of water and I have the same amount of soil, okay, not water. And I'm going to add energy in the form of heat, all right, to both of these situations. So then after I've added the heat, wait a little bit of time and I look, my temperature is 11 degrees Celsius for the water, whereas my temperature of the sandy soil, that is up above 15 degrees Celsius. So water resisted a change in temperature more than the soil did. Okay, and I know that's kind of hard to understand, but the big idea here is the reason it resists change is because it can absorb that heat. It holds on to it, okay? So it doesn't change the temperature that much. Why is this important? Well, because water can act as a moderator to regulate big temperature changes. So for example, when you look at this map, okay, this is over on the west coast here. If you look at the coastal areas, their temperatures stay relatively moderate as the temperature goes up during, the warmer seasons. But when you look a little further inland, whoa, 96, 106, I mean, that's crazy. Look how much warmer it is compared to the coastal area. The reason is because the oceans are able to absorb a lot of the heat and hold on to it, which means that the local area, the land here, is not going to be as affected by the temperature change. Okay? Also, within our own bodies, it's really good that we can moderate temperature. Think about the fact that you are constantly generating heat from all of the chemical reactions in your body. And what would happen if that heat wasn't absorbed by the water in your body? Why, your temperature would be off the charts. So lucky for us, because we're mostly made of water, the water can absorb all of the heat from those reactions, and that helps to keep our body temperature stable. Obviously, we have other mechanisms to further control our body temperature, but the fact that our bodies are made of 70% water really helps. It keeps that temperature stable.